Okay, you want to go to the moon. You want to explore new places. You want to inspire the next generation of explorers. So how do I get from the Earth to the moon? Well, the place to start is Johnson Space Center. JSC has been involved in human spaceflight for almost 50 years. That's where you start to build the spacecraft you need to get to the moon. But you need a tool to help all the different people that you need to help build a spacecraft to work together in a collaborative environment. And that's where ANTARES comes in. ANTARES starts with engineering data. The GNC engineers build inside of ANTARES a representation of the spacecraft to make sure that they can do their analysis. That representation can then be used by different people to do the work they need to do in a collaborative environment. For instance, the human factors team can use that tool in order to make sure that the vehicle that they're building is something that can be piloted. The crew can use that tool to make sure they know how to operate the vehicle and they do it successfully and accomplish all the mission objectives. Then you have operations that uses the tool to make sure that they can operate the vehicle properly, that the telemetry and the checklists will all work properly to ensure that the vehicle not only is successful, but comes back safely.
ANTARES is a critical tool for the project because it allows us to look at performance from both at the very start on the design side and development side, but also utilize it in the real-time environment with the interface with the crew and the ground operations. And also provides us the depth that we need from a subsystem perspective because it has not only tools for the trajectory and the guidance navigation control system, but also has capability to incorporate subsystem failures from the propulsion and other areas.
Engineers develop a representation of the Orion vehicle in the ANTARES tool to make sure that the vehicle is able to go through each of the different flight phases, including ascent, orbit, and entry. By building this foundation of engineering capability, each of the other teams that need to build the spacecraft can leverage off this representation to do the work they need to do in their domain.
Our team uses ANTARES to develop the design of the guidance, navigation, and control system for PA-1 and to verify its performance. Our team uses ANTARES to collaborate across several centers, including Langley Research Center, Johnson Space Center, and Dryden Flight Research Center, and it allows us to integrate in the capabilities of the simulation into all phases of the program, including design, verification, and operations.
So the next phase of vehicle design involves hardware in the loop. Our good early engineering design analysis now has to be implemented in hardware that can actually fly a mission. The transition from design to hardware happens in a lab locally called Kedalion. This is where engineers evaluate the design in a hardware environment. So we have real flight computers, we have test stands where we mount hardware, we interface everything together in the lab. But this is not like designing a car or an airplane. We still need to represent the virtual environment, the operational environment that the vehicle has to go through. And that's where ANTARES comes in.
So to me, ANTARES is great because of its flexibility and the way that it's easy to integrate in different pieces that can be interfaced to software models or interfaced to hardware models and real hardware, and it just gives me a nice flexible way of doing my job.
One of the key benefits of ANTARES is that it allows developers to work concurrently to design the vehicle. In this case, the human factors team is working with the crew to develop the cockpit that will be used for the crew to interact with the vehicle.
The thing that ties this facility together is the ANTARES simulation. That's an engineering simulation that's used to look at display and controls and pilot interaction. An example of how we've used that here is we looked at windows very early on during an ascent phase of flight. We found that through simulation that when the crew looked out the windows, they could not see the Earth horizon. From this analysis, we went ahead and fed back changes to the Orion spacecraft, and we actually changed the look and feel of the cockpit. We moved the windows up and we made them slightly larger.
So you've seen ANTARES applied to engineering analysis, crew in the loop, and human in the loop analysis as well. And all those are very important to work on design of the vehicle. But we also need to take into account the operations aspects. The operational aspects have to be involved as early as possible in the vehicle design to ensure that we are creating a vehicle that can be supported from the ground.
Mission Control Center is where NASA controls all its manned spacecraft from. The OTF is a prototyping lab for the MCC. So the big thing that ANTARES has given us is the ability to work with telemetry, to work with data flow, to work with comm, and learn how to build this new spacecraft.
So why is ANTARES different? Well, in the past, each of the different groups that needed to build a vehicle would have to build their own representation of the vehicle itself. You'd have human factors, engineering, operations, each one of them trying to build a representation that would support their needs. The purpose of Antares is to leverage maximally off the good engineering work that's done early to design the vehicle, but then to leverage off that representation for all the various aspects of vehicle to construction. So the engineers will build Antares, they'll use the best possible highest fidelity models of the vehicle in order to do their engineering analysis. That forms the core of the representation of Orion that then can be used by human factors folks as they're designing the cockpit, out the window views, things like that. It can be used by the crew to make sure they know how to operate the vehicle successfully and safely. And it's used by operations to make sure that they understand how to interact with this vehicle and can ensure that it comes back safely and successfully.